Hello everyone, this is Mangaveni, Professor, Head, Department of Chemistry, St. Joseph's College for Women, Visakhapatnam. Today we are going to discuss about amino acids. What are these amino acids? Amino acids are organic compounds that contain amine and carboxyl functional group along with a side chain specific to each amino acids. Where are they found? They are present in all protein matter. Every living organism of protein is made up of amino acids only. The protein is present in all the living organisms either in the form of a muscle or in the form of a tissues or hair, horn, etc. Right? So, protein is a macromolecule and amino acid is a monomer. So, proteins are huge macro units made up of n number of amino acids. These amino acids are joined each other via the peptide bonds. As you can see, amino acid is an organic compound with amine and a carboxyl functional group along with a straight chain which could be either an alkyl group or an aryl group, which will be the key component in every amino acid, where you find carbon, hydrogen, oxygen, nitrogen and all other elements which are found in the side chain. Well, you can find in the general structure, the amino group and acid group are attached to the same carbon, then we call it as alpha carbon. Depending upon the amino group which is attached to the adjacent side chain, you can call it as beta, gamma, delta amino acid, where the amino group is attached to that particular carbon. So, you can find amino acids are a composite which is having one end a carbon carboxylic end, the other you can find it as amino group. Let us see the classification of amino acids. You can find the three different categories of amino acids. First category, which is based on this the source: essential amino acids, non-essential amino acids. Second type of classification is based on acidic amino acids, basic amino acids and neutral amino acids. Third category of classification, we can classify them into alpha amino acids, beta amino acids and gamma amino acids. Let us see each category separately. List of essential and non-essential amino acids. What are these essential amino acids? Essential amino acids are the one which are very much important to the body. Every amino acid which are naturally occurring, this are about 20 amino acids which are present in every living human body. That means out of which 9 to 12 amino acids which are essential to the body and remaining are non-essential. Means non-essential means the body which can able to synthesize on its own. So the examples such as glycine, alanine, arginine, asparagine, aspartic acid, etc. are the one which the body can able to synthesize. The one which it cannot synthesize, they are to be supplemented through diet. So what are they? They are the essential amino acids which are to be supplemented through diet, namely histidine, leucine, isoleucine, valine and phenylalanine, right? So these are to be supplemented through diet every day. Second type of classification is acidic, basic and neutral amino acids. What are acidic amino acids? Acidic amino acids are the one which contains, apart from amino group and an acid group, an additional carboxylic acid is present in the side chain. For example, in ascorbic acid, you can find carboxylic group which is present at the beta position apart from the regular amino and carboxylic functional group. So also in glutamic acid, you find one carboxylic acid and one amino group on the first carbon, and you can find an additional carboxylic acid group on the gamma carbon. So these are considered to be acidic amino acid which contains one or more acid groups. While basic amino acids, apart from the required one amino group and a carboxylic acid group, you will find more than one amino group or in the any form of nitrogen that is considered to be basic amino acid. That is, let us see, in arginine you can find three additional nitrogens which are present, so it goes into the basic category. What are the neutral amino acids? Neutral amino acids contains equal number of amino groups and a carboxylic acid. In all the amino acids, we find at least one amino group and one carboxylic acid group. Now moving to the next category of classification, that alpha, beta, gamma amino acids. Alpha amino acids are the one where you can find the carboxylic acid amino group are attached to the alpha carbon along with the side chain. Now this you can see not only in the functionality but also in the form of its ionic state. We are going to shortly discuss about this ionic nature. Second, beta amino acids. Beta amino acids are the amino group which are bound to the beta carbon rather than the alpha carbon. Then we call it as beta amino acids. And such amino acids are found biologically about 20 of them. The more commonly naturally occurring beta amino acid is beta alanine. And this beta alanine is an optically active, hence it is obtained as L form, and also alpha alanine and a beta alanine is also available. Such possibility cannot be seen in presence of glycine. Glycine is having only one alpha carbon to which an acid group and an amino group is attached, and which lacks asymmetric center. Hence, it cannot able to exhibit this L form and S form. Now, let us move to the gamma amino acid. The gamma amino acid where we can find the amino group is present not adjacent to the alpha carbon or a beta carbon, but it is absolutely present on gamma carbon. Hence, we call it as gamma amino acid, and such example we can find here, that is butyric acid. Let us move to the synthesis of amino acids. Amino acids can be synthesized conveniently by amination of alpha halo acids. Starting from alpha chloroacetic acid, by treating with 3 moles of ammonia at 50 degrees, we can see that immediate salt formation. That means you can find there the replacement of a halogen by ammonia, and second molecule can be added on carboxylic acid in terms of ammonium salt. The loss of ammonium chloride can be visualized in this process, and which upon further hydrolysis gives us the amino acid. The second method, synthesis. This is very popular synthesis which is exhibited by all amino acids can be synthesized by this method. This stereosynthesis, the main components involved here, any aldehyde reacts with HCN, which involves the formation of cyanohydrin. Here in this equation, we can see that formaldehyde is reacting with HCN and cyanohydrin after the formation reacts with ammonia to form amino group is added there. Next, subsequent hydrolysis results in glycine. Stereosynthesis is popular. The reason that it is so simple, you can able to generate any required amino acid by choosing the right aldehyde. This reaction can also be synthesized under green condition too. The next synthesis is Gabriel phthalimide synthesis. This involves by starting with potassium phthalimide by chloroacetic ester in presence of HCl. Which leads to the formation of attaching the carbon chain to the nitrogen of the phthalimide. Subsequent hydrolysis gives up breaking down to phthalic acid and glycine. Next synthesis is malonic ester synthesis. This synthesis is carried out initially by taking with malonic acid. Malonic acid upon esterification gives malonic ester, and this reacts with alkyl halide in presence of sodium methoxide. This alkyl group is added on to the side chain, and subsequently aqueous KOH in presence of HCl takes up alcohol and which is giving rise to dicarboxylic acid. This dicarboxylic acid for the reaction with bromine replaces one of the hydrogen and a bromo dicarboxylic acid is obtained. This bromo dicarboxylic acid upon strong heating giving rise to alpha bromo carboxylic acid, which on amination gives amino acid. There are certain limitations involved in malonic ester synthesis, where you can see that initially we start with the malonic acid and the groups are protected by converting them into an ester, and then deprotection had taken place. So protection and deprotection results in low yields. And another important reason involved for the low yields is as the number of steps involved in the synthesis, the yields goes down. So this is not an advantageous method. The next synthesis is azolactone synthesis. In this azolactone synthesis, where starting from simple amino acid means such as glycine, you can able to convert and get larger amino acid. Moving to the next physical characteristics. These physical characteristics where you can see that amino acids identification. Physical properties of amino acids. The first important characteristic property of amino acids is optical activity. They are highly optically active compounds, except glycine. Glycine lacks in asymmetric center, thus it cannot be optically active. The rest of the amino acids are optically active and they can able to exhibit two isomeric forms. The second interesting property is salt-like nature. Like salts, it can exhibit both the charges, positive charge and the negative charge. Readily shows the melting points and the solubility is into any of the polar solvents as they have the charge separation with the molecule. They're readily soluble in polar solvents like water, alcohol, and ethers, etc., and insoluble in nonpolar solvents. Moving to the next, amino acids exhibits the dipolar nature. They are represented as dipolar ions. As one end holds the carboxylic acid, the other end as amino group. So, as general process, you can find an acid reacts readily with a base as a separate molecules. Why can't they react when they are present in the same molecule? Yes, they do react. So acid donates H plus ion and the base along with the pair of electrons accepts the proton. Thus it becomes NH3 plus and the COO minus resulted. So, the coexistence of both positive charge and the negative charge is considered as Zwitter ion. Hence, amino acid can be always represented in dipolar ion state. Moving to the next, chemical properties. Chemical properties of all the amino acids not just listed in one single step because there are two different functionalities. One set of reactions due to acid group, second set of reactions due to amino group where only amino group responds, acid will not take part in the reaction. The third category of reactions where both acid and amino group are reacting together. So, let us discuss about the reactions due to acid group. Acid group reacts with a bases involves in salt formation and also reacts with alcohols involves in the formation of ester, undergoes decarboxylation and undergoes reduction too. Whereas amino group can also respond in reaction with the acid involves in the salt formation again. 2. Amino group reacts with benzyl chloride, acetyl chloride, hence we get benzyl glycine, acetyl glycine respectively. And other reactions where amino group can also involve in diazotization. And amino acid can exhibit reactions with non-hydrogen or complex compounds and develop a beautiful colored complexes due to the participation of both acid and the basic groups. So we come to an end of the discussion about amino acid. We will be moving to the next subtopic of peptides, which are the linkings between each and every amino acid in the proteins. Thank you very much for watching.